23 is a little bit more difficult. So you have, we're looking at now, you start with the negative 32 to negative 15. So we see that negative 32 has the bracket, negative 15 has parentheses. So we can equal negative 32, but it can't equal negative 15. So then going back to this notation, you start with, curly bracket, x is in the real numbers, and then we know that x is just in between the negative 32 and 15. So if they're negative 32, less than or equal to x, because we have a bracket, and then less than negative 15. And then for 31, it's kind of a similar situation. We have x in between these two numbers. Here we're just looking at making a number line out of it. So we have an open dot at negative 15, because it cannot equal to it. And then all the way up to 8, and a closed dot, because it can equal to it. So with those type of problems, you just have to go through those steps of, depending on what notation you're in, just looking at, where the x is, whether it's equal to, not equal to, less than, greater than, and go from there. Are there any questions on those three? Those three, we've been doing that for a little while now, so those should start to be, I know we didn't all do them for homework, but at least talking through them, we should be a little more comfortable with those type of problems. Are there any questions on those three before we move on? So today we're gonna, kind of wrap up the 4.3 task, and then we're going to be looking at specifically the go part of 4.3. So we're still looking at solving these equations, and so I mainly want to talk about 5 and 6, which are parallel. 7 and 8, I think we all did pretty well on. I just want to talk about 5 and 6. So can someone tell me, and both of these problems are pretty similar, what did we say should be our first step here to solving number 6? No, not number 6, number 5. What is our first step for solving number 5? Multiply by what? The reciprocal of what?
2 divided by 5.
So what's the reciprocal of 2 divided by 5?
2.
So we're not language 5 divided by 5 by 2. There we go. So essentially how we got to this is we know that the inverse of dividing by 5 is multiplying by 5, and the inverse of multiplying by 2 is dividing by 2. So when we multiply by that reciprocal, these just cancel out to create those identities. So we just get 1. And then when we do the one side, what do we have to do to the other? Same thing. So multiply it by 5 divided by 2. So this just becomes 1. So you get x plus 3 is equal to 15. So then from here, we should all know how to solve this. What's our final step here? Once we get x plus 3 equals 15. Minus 3. Yeah, so that gets us x equals 12. But the key is, you could have, I know at first a lot of people wanted to distribute this, distribute the 2/5, and then go from there. You can do that, but it's not the best order to do this because it's going to make your life a lot more difficult. You're going to get fractions that you're not going to want to have. So it's really good to start by multiplying the reciprocal of that fraction to just cancel it out and get ones. So then it just becomes a pretty simple one step. And so here, this problem is extremely similar. We follow that same process, but now the only difference is it's x plus y is equal to 15. So now what should we do now to solve for x? Even though that y isn't a number, we still have still do the same step? Minus y. So instead of minus 3, now it's just minus y. Now, what's 15 minus y? Can that be 15 minus y? Exactly. Those aren't like terms. They can't be combined anymore, simplified. So that is your answer. So I just wanted to kind of re-go over that real quick to make sure we all understood.
Would it not be 15 minus y divided by x?
So 15 minus y divided by x? What's making you want to divide by x?
See x right there. Divide by x.
So but here you didn't want to do 12 divided by x.
Oh.
So remember when we're solving for x, we always want it to get x by itself, or x equals something. Now if you did divide by x, you'd have 1 equals 15 minus y divided by x, but then we still want to solve for x for that point. We always want to get to where we have x equals something. Are there any questions on those two before we move into what we're doing today?
Sure.
Come on, Mr. Lipham, let's move along.
Move on, all right. We all feel good, we'll keep on going. So now I want you to go to the go, oh, it's in the go section. This is 26, we're gonna work on 26 through 31 today for our quiz, our understanding check tomorrow. So let's start with, what did we say? We're talking about properties of equality. What is the property of equality?
Do one side is good as the
What you do to one side, do the other. Good. So, any guesses what the addition property equality is?
Once you add one side, you add to the other.
That's lovely.
What about the subtraction property of equality?
Minus one side and minus the other.
Alan, what do you think the multiplication property of equality is?
Sorry, I came in late.
You good? What do you think the multiplication property of equality is?
That's right, that I've been saying.
Yes. Perfect. So we said the addition property of equality is what we add to one side, we add to the other. Subtraction property of equality, what we subtract to one side, we subtract to the other. So what do you think multiplication is?
But you multiply on one side, you multiply on the other.
Exactly. What about division?
But you divide from one side, you divide from the other.
Exactly. You know, it's not a trick question, so,
I just didn't hear it fully, like, what was
oh
going on.
no, you're good. So, like I said, we talked about the property of equality as a whole, but when, so we knew that it was what you do to one side, you do to the other. But now, the reason I'm putting these specific names on now is so today what we're doing is we're gonna, you can see they have an example on, they didn't number it, but when you're solving these equations, so here they added 6 on both sides. So they justified by saying the addition property of equality. And then, once they did that, they divided each side by 3 to use the division property of equality. So today, we're gonna be solving these equations, but on the right-hand side of the table, we're gonna be justifying which property we're using. And then the only other property is the distributive property. When do we use the distributive property?
When you distribute something.
Exactly, yeah, it's that simple, it's just when you distribute something. So, the reason we're doing this today is because you will see it a little bit tomorrow on the quiz. So, what we're gonna do today is, we hopefully will be able to finish this 26 through 31, just solving these equations and then justifying which property you're using in each step. Are there any questions before we get going? Awesome, looks like you're already on the move, so let's do it.
So find that area. Not the back sheet.
Want me to shoe? What, do you think they're wrong?
No, they're right, but tell me they're wrong until they're right.
Okay.